Hey guys, thanks for coming out. I see a few people are following in the back, but thanks for coming out to see us. So we're going to take you through some of the new security features that are coming down the line in the Hadoop ecosystem, and sort of show you specifically how this plays in with very fine-grained and dynamic security for both Hive and for Spark. I'm Carter Shanklin. I do product management at Hortonworks, mostly focus on Hive and HBase. And I'm joined today by Bosco, one of the members of the Ranger team. Bosco, if you want to say more.
Yeah. So I'm Don Bosco Dorai. I'm an enterprise security architect with Hortonworks. I'm also a committer for the Apache Ranger. So what we're going to do today is going to demonstrate how you can do fine-grained security for tabular data, which are stored in S3 or HDFS, and accessed via Spark SQL, Hive, Pega, MapReduce. The flow that we are going to follow today is we'll see what is currently available from the security point of view when you're using Spark SQL, Hive, and MapReduce, and Pega. Then we'll see what are the challenges that are there. Then after that, we'll give a brief overview of Apache Ranger and LLP. These are the two technologies that is used to implement the fine-grained security for tabular data. We'll go over a few use cases, and we have a live demo. And finally, we'll see where Apache Atlas fits in the entire equation. So for today, if you're using Spark SQL or Pega or MapReduce, then the only option that you have from the security point of view is what the storage gives you. So if you're using HDFS, then you can set the policy at the level of the folder or the file. That means if you're giving certain users access to the folder, then that user can access all the data set that is in that particular folder. So if you want to do any column level access control, then you're out of luck. The only option that is left for you is to use something like iServer2 and route all the calls through iServer2, because iServer2 will give you access control at the level of database, table, and columns. Even if iServer2 works for you, there are other challenges when it comes to some advanced requirements, like if you have a requirement where you want to dynamically restrict the rows based on who the user is or who the user context is, then you need to start creating views for every user and every user context. And if you have requirements like masking of columns, then you need to write custom UDF and wrap it with views. So now you're going to have multiple views. Now you need to create them, you need to manage them, you need to give access control for each and every view to their specific users. And you also have to now inform the user which views they need to use. So this is pretty painful. So what we did is we took a step back and see how we can make it easier for the users to access the data, regardless of which tools they are using. And also at the same time, we want to make it easier for the administrators to set up the policies for them. So we use Apache Ranger, which does centralized policy management to define the policies. And also we use LLP to enforce these policies. So I'm going to give a very high-level overview of Apache Ranger, and Carter after that will give an overview of LLP. So Apache Ranger has three top-level functionalities. One is authorization, second is Ranger KMS, and auditing. On the authorization side, Ranger provides you a centralized administration portal where you can go and define the policies for all the components within the Hadoop ecosystem. These policies are pushed down into the component and enforced at that level. On the Ranger KMS side, it helps you manage the keys that is required for the HDFS TDE. That's the encryption solution provided by HDFS. So it creates the encryption keys and stores it within its own database. It does all the access control and auditing required for that, and also has integration with HSM if you really want to use HSM to store the keys. Then on the auditing side, what Ranger does is it normalizes all the audit records to a standard format and sends to a central location. Currently, out of the box, Apache Ranger supports Solar and HDFS as the destination. Solar is used for real-time querying and for visualization, while HDFS is used for long-term archival. From the architecture point of view, Ranger has two components. On the top, you see the administration portal. This is where you're going to come and define all your policies. So that the Ranger admin has its own RDBMS where all the policies are stored. It provides you a UI interface where you can go and create and manage the policies. It also has a REST API if you want to manage the policies using programmatically. Below, we have all the components. So Ranger has something called a Ranger plugin, which are very lightweight Java code, which runs within the process of the component. So it does a couple of things. First, it replaces the native policy engine. Then the Ranger plugin pulls in all the policies from the central repository and enforces them as for each and every request that comes through the component. Since the Ranger plugin replaces the native policy engine, it has the ability to add more conditions. So it has a design concept called dynamic policy, which can be extended, and you can write your own condition if you want to. So out of the box, Ranger has IP-based conditions, it has location-based conditions, it has time-based conditions. Even the tag-based policies are implemented using the dynamic policies. So what we have done is, for the fine-grained security for Tabular, we have extended the dynamic policies to implement these conditions also. So I'm going to give it to Carter to talk about the LLP.
Okay, thanks. So thanks, Bosco. That was a great overview. I'm going to talk a little bit about LAP and how it sort of, we've got a lot of things floating around here. We've got Spark, we've got Hive, we've got LAP. I want to kind of give a landscape of how these pieces are fitting together, but also we've got a very nice demo that we're going to leave time for that really shows all of this in action, the truly dynamic nature of different users seeing different results, seeing different values, just based on the policies that are stored within Ranger. So we'll leave plenty of time for that, but let's sort of dive into it. So LLAP is part of Hive 2.0, so which was recently released within Apache maybe a few months ago. And Hive 2 is actually quite a very large release. Several thousands of improvements had gone into that. And those of you who have been with Hadoop, you might know that Hive has been long established as a data warehousing system on top of Hadoop. For almost 10 years now, this is a technology that people have come to rely on. And many people have used this, but in our customer base at Hortonworks, people have been continuously saying to us, hey, we want to put more workloads on Hadoop. We want to put more SQL on Hadoop. We need faster performance. We need interactivity. We need low latency. And so a couple of years ago, we sort of looked at this architecturally and said, in order to get to this next level, how are we going to sort of deliver that within Hive and within this open source community? So what we arrived at is, if you're really looking to get interactive query, there's some critical things that you need to do. To get truly low latency and interactive query, you need to basically run persistent servers that are always on and always ready to process queries and process SQL. In addition, you need to sort of tie that up with intelligent in-memory caching, and that's kind of the root of the idea around LLAP. So LLAP really builds on a lot of the Hive engine pieces from an execution point of view, from a SQL point of view, but it adds this new component of long-running processes, intelligent caching, and the ability to sort of read from HDFS, from S3, cache that data intelligently and serve it out. So what does this have to do with things like Spark and Spark security? So that might be a little bit less obvious. Obviously, the main goal that we were looking for with LAP was low latency query, low latency SQL. But we've also seen, as we've dealt with Hadoop for many years, we see a lot of value and a lot of power that people will get when you have open interfaces and composable interfaces that other people can implement and read data, put data in, get data out. So within LLAP, essentially we have extensible interfaces that allow other participants in the Hadoop ecosystem, Spark in particular, to be able to read data out of LLAP and then do what they want with that data, while at the same time relying on LLAP to be sort of that trusted service that delivers things like security, delivers things like masking, delivers things like row filtering. without having to rely on client-side mechanisms which could be circumvented. So I'll talk about very specifically how these pieces all link together in just a moment. But let me step back a little bit and say Ranger and Hive have had an integration that has existed for a few years now. So let's talk a little bit about some of those basic capabilities. Within Hive and with Ranger, Ranger for quite a long time has had the ability to do basic authorizations to say, these users are permitted to access these tables, but not these tables. So you've had authorization at a fine-grained level at the table level or at the schema level. More recently, we've added dynamic policies, and this is what we'll be showing in the demo, but dynamic policies that allow you to say, on a per-user basis, we want to do column masking, or we want to do row filtering. So you can say, if you have sensitive information in your database, you can say, you can store that data raw in its sensitive form, but when a user goes to query that data, on the fly, that data will be masked, or on the fly, that data will be filtered. All of this is driven by policies that you define within the Ranger server. And it's all dynamic based on the requesting user. In addition, all of this happens as ordinary SQL commands, ordinary SQL syntax. So Ranger essentially does what is the equivalent of a query rewrite. So all of this is just executing as ordinary SQL queries within Hive itself. So what are some of these capabilities that Ranger is introducing with respect to the dynamic masking and the dynamic filtering? First of all, what are we saying when we talk about masking? You know, fundamentally, at its most basic format, masking will take some text, it will replace all the characters with a letter X, replace all the numbers with a letter N. And so you see a few examples of how this works with respect to things like social security numbers and so forth. So the good thing about this is you protect the actual value of the information, but you preserve some of the format, so you can kind of tell what this is. Very commonly, we'll see, you know, what are the last four digits of your social security number? A very common question that you'll get asked when you call any customer service hotline. So you kind of see that format is preserved, but the data itself is protected. One other capability is hashing of values. So if you ever have sensitive information, you want to sort of obscure that value, but sometimes you need to be able to join tables together based on some kind of a key. That key could be something like it could be a sensitive value, like a social security number. This hashing is consistent across all of the tables and allows tables using a common key to be joined together without revealing the value of that sensitive information. Okay, so how does this sort of fit together and deliver security on Spark? So on the right, we kind of see the workflow here. Very crucially, in delivering Spark security, there are a couple of things that are extremely important. Number one, Spark has its own execution engine. It's going to manage its own, it's going to have its own SQL dialect, its own execution engine, and so forth. So, Spark needs to be able to deal with this data in the way that it sees fit. But secondly, Ranger is the component here that applies those query transformations that will bring these policies, the masking, the filtering, all of this to the table. So we need some way within Spark to be able to say, I want to just deal with the data in a somewhat raw way, but then sort of delegate all of the decisions about runtime and execution to Spark itself. So the way this is implemented, and a little bit of some of the technical details here, essentially what we have built is a plugin into Spark called the LLAP context. This plugin is aware really of, number one, the LLAP daemon itself and how to read data out of LLAP. And number two, it's also aware of the query transformations that Ranger may apply to the Spark queries. So basically what will happen, you issue a query, Spark SQL will reach out to Hive Server 2 and to Ranger to get data locations. Ranger will, based on the policy, it may do some query rewrites, but it will return a set of locations in sort of the Hadoop technical terms. These are called splits. And that allows data to be read in parallel from the LLAP server. So Spark SQL reaches out, it sort of, the query transformations happen, you get a set of data locations back, you read those with a signed plan from LLAP, you can read this all in parallel, and from there on out, Spark SQL is free to do whatever it wants. It can do its joins in its own way, all of the other SQL things that it needs to do can happen in its own way. So at the same time though, LLAP will be, as a trusted daemon, LLAP will be doing things like masking of values, row filters, and so forth. Okay, and again, we'll see, here's a highly simplified example of that, and then we'll jump into a demo. But let's take an extremely simple example here. We have let's say we have a customer table. It's a very simple thing. We've just got user IDs, regions, and sort of a net spend. And what we want to be able to do is say, some customers are in the East region, some customers are in the West region, and there are sales associates in either of those two regions. We don't want sales reps in the East, sort of looking at customers in the West, trying to poach that business, something like that. So what we want to do as policy administrators is we want to say, sales reps in the East can only see customers that are in the East. Sales reps in the West, similar story. But these sales reps, as they're going in, they're doing ad hoc analytics. They just want to issue their own SQL queries. They don't want to have to worry about these policies, which are hidden from them. What we see here and the way the policies are implemented, these sales reps come in, they just issue their regular SQL query. In this example, we just want to say, give me all of the customers that spent more than $10,000. They just issue that just as a very simple thing they want to query the database to do. Based on the policy that we have here, Ranger is going to make essentially query rewrites to this query to say, well, we want to inject this additional condition. If you're a sales rep from the East, we want to have this where condition that says you're only allowed to see customers from the East and vice versa. So what the user issues is just a very basic, simple SQL query. This is morphed a little bit based on the security policies, and we at the net result is people have the appropriate level of access just based on policies that an administrator separately controls. Okay, so let's move on to maybe a little bit more, not a complicated, but a little bit more of a real use case, and then we'll actually demo, Bosco will be demoing the same thing, but let me kind of zip through this to get to the demo and leave some time for questions. So in this demo, we're going to have just two tables. We have a users table and a sales table. Pretty simple. These two tables are joined by a key of customer ID. So we have a number of users. They make a number of sales. There's always a relationship between these tables. On the bottom right, we see there are three sort of profiles or users who might come in and do SQL queries against these tables. First of all, we have Frank in the fraud detection department. So Frank is able to, from a row filtering or a user filtering point of view, Frank is able to see all of the users, but we don't want Frank to be able to see necessarily all of the information. So let's kind of work through this. Actually, if we step back, the first use case we want to have is, there's sensitive information in this users table. For example, we've got the credit card numbers there. Some people should be able to see this information and some people should not. So Bill in billing, it's okay for him to see that credit card information because he's got to charge that stuff. But the marketing department and others should not be able to see that. So what we want to do is we want to have this one table, all the data is there. We want some people to be able to see that, some people to not be able to see that. We want that to be a policy that we can apply within Ranger. Secondly, we might want to do some masking because there's sensitive information here like people's names and emails and phone numbers and stuff like that. Bill in the billing department, he needs to have access to this information again. He might need to send out letters and so forth. But Frank in the fraud department, there's no real reason for him to have access to this information. For him, he's just doing more pattern matching, anomaly detection, he doesn't need to be seeing people's credit card numbers, for example. So we're gonna mask those values from him. We're gonna sort of obscure all those values so he can't figure out what they are. In this case, in this use case, what we're gonna go through is Bill in the billing department. He's able to see all of the users, but Mark in the marketing department, we are going to restrict his access to only see users with a state of California. So he's only able to see those particular users. And the last use case that we're going to talk about, something that is a little bit more sophisticated, is we have this sales table, the users table. They're linked by a key, but a user might come in and they say, I just want to query the sales table. Let's say I'm Mark in marketing. I'm supposed to only see users from California. What happens if I go in and just query the sales table? Because there's no state in there, right? So am I going to see all of the sales? Or should I see just a restricted subset of those sales? Just restricted to the users who are in California, which I can only figure that out if I look at that other table. And with the policies that we actually have the ability to impose that policy. If you're Mark, you're only able to see the sales data for the users in California. And the way we do that is essentially by injecting certain join conditions and certain matching conditions on the fly within these Ranger policies. So I think that kind of sets a background, and Bosco's going to sort of switch us over and do a demo of this stuff on the fly.
Yeah. So the first use case is we want to restrict the user to certain users to not see a few columns. Now, this is a very standard use case that we support right now in iServer 2. So if you're going to iServer 2, you can do it right now. But if you're using Spark SQL and all that, since you're going directly to the folder or file, you can't do it. So with this LLP integration, we can do it. And the good thing is, from the administration point of view, now everything is the same. You don't have to do anything more to support it. You can just go and create the standard policies as you might have done before. So first thing I'm going to do is I'm going to just show you the policy for billing, Bill from the billing group. The reason is Bill has pretty much access to see everything. So he's going to be our reference users going forward. Now, those who are not familiar with the Ranger, the way we do it is this is a policy editor for creating policies. The look and feel is consistent for almost all the components. The main difference is the top level, that's the resources. In the case of Hive, it is all about database, tables, and columns. And if you see out here, I've given two tables out here. The way Ranger works is it wants to simplify the way you're creating the policy. So you can give as many resources as you want to. So I have given two tables out here. Ranger also supports wildcards. So you can have since it's star, that means you can access all the columns. But if you want to restrict a certain column like phone star, you can do it. Then below, what I've done is I've given the group billing access to do select on the table. Okay? What essentially that means is anyone from the billing user can do a select on these two tables, and they will get all the results. So I got a bunch of terminals open. The green is for Bill, so just remember that. And I got 2 terminals per user. So this is for the Spark SQL. The query that I'm running right now is select customer name and credit card number. So what would happen is generally it'll just run the query and get you all the users for that query. I limited it by 5, so you will see 5 rows. Now, let's take another use case for Mark, where we want to restrict the user. So there is another policy which says non-PCI data. In Ranger, there are 2 different ways you can set the policies. One, you can list all the columns you want to give permission, or you could do the other way around. You can list the columns where you just want to exclude. So what I've done out here is, since Mark doesn't have access to the credit card column, I just given that particular column a field name, and I done exclude. And I given select access to Mark. What it means is, now Mark has access to do a query on this table, and you will be able to see all the columns except for this credit card. So Mark is blue. So I'm going to run this query, select customer name and credit card. So since the exception is coming from the Spark SQL, so it's going to bring nasty exception out. So what has happened out here is the query went through LLP via Spark SQL, and it was rejected as a permission denied. What we can do is we can now go to Ranger audit, and we can select the service type, Hive, and you'll be able to see that Mark was trying to access the customer credit card field, and it was denied. And if you go a little below, you'll be able to see that Bill also tried the same select query, but it went through. Okay. So this is use case 1. So let me go to the second use case, where we want to do masking. Now, both masking and row-level filtering is a new addition to Ranger. And we also wanted to make sure that we make it super easy for the users to configure. So we have 2 new tabs for that. And here you can come and pick any tables and columns and set up the policies for the masking. Now let me pick one of this policy. I predefined the policy, so it'll be, in the interest of time, so it'll be easy for us to demonstrate. Yeah, what I have done is I picked up the table users, and I have the column customer credit card number. And for fraud, the users from the fraud investigation group, I set up the masking tab as hash. So out of the box, we support a lot of different algorithms. Hash is one of them. Carter explained how the mask works, and you can do date and other things also. So this sort of uses the standard UDF. So if you want to customize it, you can write your own UDF. There are a lot of out-of-the-box UDF also available, like substrings, everything, you can use it directly. And since it follows the same policy or the same way you set up policies for Ranger, if you want some other users also to be applied the same masking, you could just pick it up. You can have as many groups and users as you want to. And if you want to apply some different algorithm, let's assume I want to apply, say, null. I can pick that one, and I can apply to some other group or users also. So the way the null works is when you're running a query, first select with the column name, and the response that you're going to get is always null. This is another way of restricting a column. So if you already have a SQL application running, you're doing a query based on customer name and credit card, if you remove the axis, then it's going to fail. But if you do it null, what will happen is the query will return properly, except for the credit card number will be always null. So that's one way of doing the masking. Yeah. So let's try out running this as Frank. Frank is from the fraud group. So I'm going to run the same query, customer name and credit card number, and let's see what happens. So the same list of users got returned. The only difference is now the credit card number is hashed. So if I go and see the billing user, it had an actual number. So what we did was we ran the same query as 3 different users, and we got 3 different results. So if you have a multi-tenant environment, or you have a different multiple line of business in your environment, a different type of users, you have a lot of flexibility of setting the appropriate policies so that you don't have to replicate the data, you don't have to manipulate the data at the lower level. So let me go to the third use case, the row-level filtering. So this is also what we have done is we made it super simple. Like in the existing solution, what you need to do is you have to start creating views, and you have to give permission for each and every view, and you have to manage it. Right? In this solution, what we have done is, as far as the end user is concerned, they will be always running the query with the actual table name. So in this case, it's users. And what we'll do is for every users or group type, we'll have a different type of predicate. If it is a California, what I've done is I've done a California state equal to California CA. So this customer underscore state is a column in this users table, so I can do a straight away predicate. In the next use case I'll show you how we do a join. So let me do one thing. Let me run this. So I'll run it as Bill first because he has access to everything. So this is a slightly different query. I'm doing the customer name and customer state. So the response I'm expecting is the users from all different states. So if I run the same query now, as mark for marketing, I'll only get the list of users who belong to the state California. Okay. And since it's all done at the lower level, you can actually do a little more complex query also. If you want to do group by, count star, everything, you can do that. Essentially what will happen is it'll just filter out only for the users they have access to. So I'm just running it on for Bill, who has access to everything. So you can see the result for all the different states. Now let me see whether I can run. I didn't run any query on the B line. Essentially, this is a different way of accessing the same data. I'm going through B-line, which actually goes to Hive server 2, so the same policy is enforced for Mark. Now, so similarly, if you want to do join, if you have a data which is in your context data is in a different database, you can actually do a join. So in fact, you can reduce the number of policies if you do a lookup. Okay. So that is the demo. So let me quickly go through Atlas. Okay. So Atlas brings in a very different view for how you're going to do your security. So it does classification and tagging. In the traditional world, when you do policies, you generally do policies at the resource level. You take a table, you take a database, or you take a folder, and you do the policy. As the number of tables or folders keep on increasing, you have to go and create more and more policies. So first of all, it's difficult to manage. Secondly, generally the Hadoop admin, they really don't know what is in the table. So now you need another business guy sitting next to him to set up the policies. With the introduction of Apache Atlas, what you're doing is you are tagging the data as it is coming into the system. So you're going to tag the tables, columns. In the future, you can tag HDFS folders. And Apache Atlas also does the governance and also does the lineage. So as the data is moving from the HDFS folders to Hive database for another table, it keeps track of the tag and carry forwards it. So what you do is, instead of trying to create policies at the level of resources, you start creating policies at the level of the tag. So this is an example of a Atlas tag-based policy where I have given, I have a tag called employee SSN, and I've given the policies for that. Now this policy will be enforced no matter which resource it is and how it is. So even if there's no resource, there's no policy for the resource. Whenever anyone is trying to access the resource, we'll do a lookup and find the tags for that particular resource and apply the corresponding policies. So in this way, now what you've done is you separated the duties. So now our Hadoop admin doesn't have to go and set up the policies, anything like that. The compliance users will come and they will set up the policy once. And then the users who are loading in the data, who know the actual data, they will tag it as the data is coming in. Now right now, this is primarily for standard access. Now we're going to extend this to also support masking and rollover filtering. So if you take masking, I can just say, if it is employee SSN, it has to be masked for everyone other than billing. So I don't even have to set any policies in the Ranger, any other policy in Ranger, because anytime who's trying to access that particular column, this will be masked automatically. Okay. So let's open up for question and answers.
Do we have mics?
Sorry, yeah.
Yeah, if you could speak up a little bit, it'd be helpful. So where's the data stored long term, though? I mean, the data frame is transient. Right, but is it a streaming RDD, or where's the data coming from? Yeah, I mean, so this protection, basically, this is good if you have the data stored somewhere the data could just be files within HDFS, and you can create external tables, or essentially this. Right. Did you have any?
Yeah, so the question is, does it apply for Spark streaming? So right now, this applies primarily for data which is in HDFS and S3, tabular data, because that's where our main plugin is. Later on, we'll look into the other way of doing it. So right now, we don't support that particular use case. Okay? Yeah, so next question.
Yeah, question about the file format. I thought it was true that LLMP is only current, at least for now, only supported for work. So that same stipulation or restriction would be there any of the new features that are going to rely on LLMP would only be for
So the
So
question is.
yeah,
sorry,
you did say question.
so the question is, just reframe your question just slightly, if I could. What file formats does LAP support? LAP supports any file format that Hive supports. So you can read any format of data through there. So Avro, sequence file, CSV, text, Parquet, ORC. I don't know, there's probably some others.
That's not what we just heard in the previous session.
So there's a difference between whether it would be vectorized from a query engine point of view or whether you can read the data through it. You can read the data through it, but you won't have the vectorized query engine going, except for workfile. But this is not a performance thing that this is primarily a security focused thing.
Okay, so I guess the main point is it'll work on all file formats.
Of course.
The security aspects will absolutely work on all file formats, yes. Yeah.
In a multi-tenant environment, I want to delegate this management of access control down to my tenants. Is that something that
So Ranger support, so the question is whether we can do multi-tenancy with that. So Ranger supports multi-tenancy by default at the policy editing side, right? Now this one will still be done, there will be some administrator will say who the tenant is. So the policy that will be generally set up in this particular case will be the administrator. So you will know for this multi-tenant, what should be the lookup. Once the rollover filter is set up, then the access control will be managed by the specific users, or specific line of business or multi-tenant. So it will be like a transparent thing.
We had a few over here. Yeah.
So can the policy be exported and imported? Yes. So Ranger by default gives the option to export and also to import if you want to. So it does that. Yeah. So.
Yeah, here.
So if you have both ACOS and also the tag, how do you perform the authorization checking when you call it?
So ACOS, and what is the second one you said?
The tags.
Okay. So how do you do when you have tags and resource-based policies? I can also add masking and row filter to it now. So there is a hierarchy that we follow. The first, the tag is checked. If you don't have the tag policy, then we go to resource. Okay. Then that's the hierarchy for that. When it comes to role filter and masking, the first we do the access. If you don't have access to the table, we just reject it. Once you have the access, then we do the row level filtering. Then whatever the result that comes in, then we apply the hash or masking for it. So that's the flow that we follow. Yeah, so the question is how do we match the actual user who's logging with the what he is allowed to. So that is more of an internal to it. Like, so when you log in as a user, you will know what group he belongs to. So what the demo that I given was the mark was belonging to the California group. So the policies was at the level of the California. But Ranger also supports dynamic lookup. If you really want, you can extend it and make it much more sophisticated. But at the end of the day, it's all about how you want to set up. If you have a lookup table, you can use it. Or if you can get it from LDAP, it's much easier.
Good.
Yeah, LDAP definitely just works out of the box.
Okay, we had a question.
Is row-level filtering a feature of Ranger or is that something provided by LAP?
Do you want to take? I can take.
No, but
So basically, what Ranger will do is apply what are effectively query rewrites to add where predicates, but the filtering is actually done within LLAP itself. So the filter push down is there, and there's some projection for things like hashing. So the reason you can't do it on the client side because otherwise you could circumvent the security. It has to be done on that server side. It's very. The column-based, even the column-based masking, let's take Spark, for example. I mean, you're just running your own UDFs at that point, and you're reading the data, then applying a UDF. You can just very easily go around that. There were some other questions. We had a bunch of questions. Sorry.
Just a quick question. So I think one of your slides referenced integration with Hive stream components. Is that part of the future roadmap, or is that something?
no, so so I didn't go in deep into that. In this current release, the NiFi community has already integrated themselves into Ranger. They build the plugin. So NiFi is supported, even Atlas is supported right now. And we are working on a few other components right now.
Well, go for it.
Does this change at all the requirement for the user coming in has to have read access to HDFS as well as
Yeah, so I can take that. So there's a couple of ways to set up Hive. Just forget everything else for now. There's saying do as equals true, do as equals false. So the recommended sort of best practice right now is to do to make Hive essentially as the owner of all the data. So the data on HDFS is actually owned by Hive, and all the reading is done as Hive. You do sort of as an impersonation. So that's kind of the recommended best practice, and then you apply the policies at the user level, but then all the data reads are actually Hive, and if a user were on the Hadoop cluster itself, they wouldn't be able to read the data from HDFS.
Yeah, so the question was whether you need to give permission to the folder.
Thank you.
So the answer to the question is, you have to give the permission to Hive. You can't do, if you are giving permission to the user, then the user can go and access the entire table, so an entire data set. So there's no protection. So only when you're going through LLP and the LLP owns the data, or Hive owns the data, the user who's accessing, then only you can, this is more effective.
Yeah.
Uh-huh. Yeah, so the question is, when you have, if you don't have access to a particular column, then you can't do a join. Even if you do a join, it'll only be a subset of it. So it's pretty safe for you. Okay. So you can't bypass the basic access. Yeah, when we get in, sorry, if someone else is doing a join, does this still affect? Yes, when we come to Atlas, Atlas will carry forward the tags and will be enforced at that time. Right now, we don't do it in this one. Okay. By the way, we are running out of time. Probably, thanks for guys for coming in. We can take questions after.
We can take a few more in the hall, but yeah. Thanks, guys.